If you want to start an argument amongst a bunch of cow people, or at least a bunch of nutritionists and management type of people, is you start talking about what the best cow size is. Because you go to some parts of the country and people tell you, oh, you need small frame, moderate size cows. You go to other parts of the country, no, I need biggest cow I can get type of deal like that. So environment plays a big piece of it, right? But really, it's where you have to match it, right? Like, so what you're really trying to do is you're trying to match the cow that can fit within the environment that you have, right? And you're trying to optimize. I mean, another good way to start a pretty heated debate is you can also talk about how do we measure the best efficiency in that cow-calf system, because should it be number of calves, should it be pounds of calf per acre, all sorts of other type of metrics in there. At the end of the day, what this all really alludes to is it's really difficult to optimize in kind of pastoral settings, more extensive systems, which is the modern U.S. beef cow-calf model. It's really, really hard to identify efficient and inefficient animals. A lot of times the less efficient cow, well, she sneaks along inside of that system, because what we really use is the metric that's typically the calling metric is the ability to achieve a pregnancy.
Yes.
So as long as she gets pregnant again, then she doesn't get called. Even though she might be taking more acres to make that calf for you, right? And so what we're really hoping to do with this specific study is we're trying to come up with a system or a solution that would allow feedback information into that cow-calf production system that allows for individuals to optimize, identify this heifer or cow is more efficient than that heifer or cow. And so if I can manage these type and kind of heifers or cows, and I can do that within my system, then what I'll ultimately end up realizing is a greater amount of greater pounds of calves, marketable calf within my farm, which I mean, like I said, we can talk about, you can argue about efficiency, but I don't think anybody will argue with me that ultimately, I mean, what you end up doing, the saleable product from a cow-calf system is pounds of calf weaned on a farm basis, right?
So will this efficiency affect milk production then? I mean, are you looking at
possibly
that too?
This study's focused on the developmental heifer.
Okay.
And so what we're really trying to do is we want to come into heifers right around that age of weaning, early in their life. And then we're going to do some things nutritionally that we think actually influence mature body size. And so we're going to feed some of them a diet that lets them grow faster versus another diet. Yeah. So maybe a higher grain, a higher caloric density type of diet. Not anything too excessive, but on the faster end of what you'd probably see in a commercial environment. And then we'll feed a more traditional, kind of a slower developmental type of diet. And we'll mix and match this across different heifers within the cohort. And then we're going to look and see how those nutritional treatments influence their surface area. We're going to directly measure their maintenance energy costs. We do that. We have systems. We have some equipment on campus. They're called open circuit indirect calorimeters. So you measure respired air. So for those of us old enough to remember what a telephone booth looks like, these basically look like a telephone booth that the animal's head's placed inside there. And then that allows us to capture all the respired air for a pretty short period of time. It doesn't take that long to capture this type of data. And we measure how much oxygen they need, how much CO2 they produce, how much methane they produce. And from that, we can actually figure out their caloric energy losses. And so if you do that in a state where they're below maintenance, then you can figure out you can directly measure the maintenance energy costs. And so what that allows us to do is take our current surface area measures. So this system that we've developed using a bunch of computer sensors, which is in place to capture surface area. So we'll capture surface area of the animal using that system, and then simultaneously we'll put it into these indirect calorimeters. We'll directly measure maintenance energy costs, and we can study that relationship and see how that changes in response to different planes of nutrition, and also in changes, so changes in growth size. And at the end of this study, what's going to happen is, so we take all of our heifers, we're going to put them through a different programming type of a system, then we're going to breed them all, and then at later in gestation, right before they calve, we're going to do this again. We're going to say, hey, how do these changes during growth relate to when they were in mid to late stages of pregnancy, so when they were developing a calf in utero. And then we're going to follow it 30 days after they calve as well. And so ask that question when they're lactating and when they have got a calf at their side. And so in order to do that, we actually have to, so we got to milk a bunch of beef heifers, because you got to count for the amount of calories that are sitting in that milk. Yeah. So you got to do things like that. So, but yeah, so we're going to do this at multiple points throughout these animals' life, so we can better understand this relationship, ultimately be able to take that information, make it more accurate, so that what we can do is you can take animals and you can ask these questions as they change different things that they're doing with their body, different products that they're making, whether they're making calf, whether they're making milk, whether they're making body tissue, and say, how's this all relate to these surface area measures? And the goal is that you come up with a system that, you know, it's pretty easy, pretty passive. I mean, we can basically set this up and you can capture surface area scans in a pretty passive sense. So it's not very laborious to actually collect this type of data. And then you can feed this back. You can translate it into a number that a lot of producers can understand. You can put it, because calories are so important. I mean, I could tell you, well, here's the caloric requirement of this one relative to that one. And so you might want to make selection decisions on that. You might want to make selections. You can take it to other things. You can say, well, this is the type and kind of grass that I am, or this is the season that it is. So functionally, this is how many acres of forage this critter is going to need in my production system, or this is the feed cost, the direct feed costs of this one versus that one.
Because you might even say, I need to switch from a spring herd to a fall herd.
You could certainly look at that
just to make use of the better efficiencies.
Yeah, so that gets really complex.
Yeah, it does. But it gets on everybody's different farm. Now, will you also follow her offspring to see how heritable this is?
So for this, so Dr. Decker, Jared Decker, he's he's the geneticist in this role. So I mean, I'm the guy who's doing the nutrition bioenergetics piece. Guy D'Souza's he's the one who makes who facilitates our ability to capture these 3-dimensional images. Dr. Decker's going to come in, and we're going to genotype these animals, and so we're going to try and identify the genes associated with the more efficient and less efficient animals as determined and as it relates to surface area. So hopefully what you can actually do is come up with better genetic predictions of efficient and inefficient cows, because ultimately you want to do two things. So, I mean, a lot of times I'm the nutritionist, right? So, I mean, the way I like to tell a lot of people, when you think of like nutritionists and geneticists, for the most part, nutritionists is kind of like a car mechanic, and geneticists is kind of like the engineer, right?
Oh, sure.
So the engineer makes the problems, and the mechanic's got to fix them, right? And so really, what I hope to do is, I got the cattle that I got, and I'm just trying to make them the best thing that they possibly can be, right? Because that's in real time what I'm trying to capture value off of, right? I'm not insensitive to the fact that we also need to make the next round of them as well,
right?
And so what we're hoping to do is twofold, right? So we can figure out how to optimize the value of what we got with a system like this, but hopefully we also are improving the tools that we have available to make a better next round. So then the next round that comes by, well, they're even better than the last one, right? And so we get better as time goes along as well.
Because all you did, but when they go up to drink, you get their weight, and also you have this little machine scans them really quick.
You got it. It's just a whole bunch of sensors that we put around them, and there's various ways that we can trigger it right now. And so, but yeah, you can certainly use waters as a location. You can use bunks as a location. You can use working facilities. It just depends. That can all be adapted quite easily from with the system that we have. So,
and like you said, the average is 44 cows, average nationwide. So this could be used on all sizes of.
Well, and yeah, so that's what we're really trying to hope for. The average of the U.S. beef herd is 44 cows per operation. And, cows are obviously very valuable, but, a lot of times that's not enough when we, even with the price of calves where they're at right now, a lot of times that's not enough to cash flow some really expensive equipment, some real laborious type of things, right? That's why, we see a lot of people use cows. I got cows on the side type of thing, right? I got some cows at home and I do this thing, but, I'm also working and doing things like that. And so what we're hoping to do is come up with some systems that you can actually provide solutions for producers like that aren't very intensive. They're based on some intensive biology, but from the ability to capture the data and the accuracy of the data are not, the accuracy is very good, but the ability to capture the data is maybe not too hard. And so what we can do is you can provide some real-time feedbacks for some folks who otherwise don't have that information at their fingertips right now.
Or I could be if I'm a smaller producer, but I want to buy your heifers to breed because I know they're efficient.
Yeah, so marketing is at the point of marketing is one of the places where I think of this as being one of the most critical times to be capturing this type of data.
Yes.
I mean, and for the most part, cattle are marketed traditionally 2 to 3 times at least in their lifetime. At least terminal animals are, and non-terminal animal. Well, all of them are 2 to 3 times in their lifetime. Some of them just happens within a year or two. The heifer, we can do exactly like what you just suggested. I've got her weaned off, and maybe you want to buy her to breed her. Maybe you want to look into a different development type of things. So you might target a different animal, one type of animal versus another type of animal because it fits within your resources, or you might make some informed management. Maybe you decide, well, I like the genetic makeup of those, but right now they don't look like it looks like for me to really capture that or for those animals to be successful. Maybe I need to manage them in this way versus that way. To really set them up for success so that I can have a higher pregnancy rate, so that I can, either first or second calf pregnancy rates, which is a lot of the times the biggest challenges that you run into in keeping a heifer around in your herd. That's where a lot of the times they'll fall out because they don't fit in the system. Right.
Because a lot of people, if they don't breed back that first cycle, they're gone.
Yeah. That's typically the number one calling metric that a lot of folks use in their.
Right. So would it be worth, if I'm trying to build my herd good genetics, to purchase some of those? I'll put up with that just to get that good genetics to get something started.
Sure. I mean, it's optimums, right? Like I think that's and this is no different from all of it. Like, I think we get it's a very human thing to kind of to focus on the extremes, right? The best, the worst, right? But for a lot of things in biology, particularly with managing cattle, sometimes it's kind of like that Goldilocks type of deal. It's like, this one's too hot, this one's too cold, this one's just right. And so sometimes it's really hard to when we're not looking for the extremes, right? To really look for the one that's optimal, right? And so if it was easy to do, we'd already be doing it, right? And so we're trying to actually kind of give people that information. You couple that with some other information about your operation, you can really figure out what you're doing.
So if here in Missouri, I'm seeing a lot more folks talking about grass-fed, grass-finished.
Yep.
Is there a different type of animal for a feedlot versus a grass-finished?
Well, so I think so. So like I said, draw it back to grass. So if you got the forage out in the pasture, so that's typically one of the cheapest ways to get calories into a cow is to let them go graze it, right? Because the energy content of stored forages like a hay is about a third of other types of feeds that we harvest, like corn. But hay doesn't cost a third of the price of corn.
Right.
A lot of times feeding things like hay is really expensive. So you can do grass finished as a system to do that. A challenge to grass finish is, while it's cheap from a standpoint of getting calories into the animal, it takes them longer to grow, right? Because there's less calories per blade of grass or per acre out there than there is in maybe some traditional finishing diets. And so there's probably animals where you can optimize their ability for growth in those systems versus other systems. What happens right now in a finishing scenario is basically we're treating all cattle like they're race cars, right? So we've got all this. I mean, the beef industry's been great at as really learning how to optimize the way we feed the best calf, we've got various technologies like implants that we use, beta agonists, some other feeds type of additives that really optimize growth. And so we use these things, and those things all work really, really well at getting the most out of the best calf. But the average calf, sometimes those things don't pay off quite as well, right? Because maybe some of those, they can't capture the value in all those technologies. So that's where but the consumers, beef consumers, are very interested in other types of production systems. Some like grass fat program, non-hormone treated programs. The challenges with some of those programs is that we give back some production efficiency, right? They grow a little bit slower, and things like that. And so there's, at the producer level, there's always this kind of conflict. It's like, well, I can do this type of system, but am I losing some value that I could have otherwise captured? Well, if we can identify the animal that maybe had less value anyways, because it had less potential to capture all the value in our current finishing systems, well, maybe we can optimize the value that we can capture out of those animals by putting them into some of these other production systems, into the grass fat system, into a non-hormone treated system, things like that.
Yeah, because if you put a race car in the grass fed, they may not benefit there as well.
You're not going to win too many NASCAR races with 1984 Yugo, right?
That's right. I mean, that's right. So, the other thing that intrigued me is that you put them over in these, I can't remember what you called them, where you measure CO2 and methane emissions.
Sure.
Efficiency comes into that too, doesn't it?
Yeah. So that's a big piece on how we change things. Cattle, there's a lot talked about with their methane, the amount of methane that's lost. So that gets into some more of the internal mechanisms of how things are happening within the rumen and other parts of the body as well. So, I mean, CO2 roughly represents basically fuel in the body that's been oxidized, and then methane itself has energy content in it, and that happens that's a consequence of fermentation, of pregastric fermentation. The cool thing about this is, so there's a lot of really complex things that happen within the body that are what lead to differences in energy requirements. And those can be going in lots of different ways, and they can go in a lot of different ways across different individuals. But because energy is neither created nor destroyed, even though
law about that,
even though we might have all these different complex things going on inside the body that contribute to that, if I can measure the heat loss from the surface of the body, well, it doesn't matter that if one calf has a higher maintenance cost because this stuff's going on versus this other calf has got an elevated maintenance cost for other reasons. Those should both be directly proportional to heat losses from the body.
Yeah.
And right now we think that those are directly proportional to the surface of the body. So really what we can do is we don't have to get lost all the time in some of these other things that are happening within the body, because we can capture some things that we know about thermodynamics and how energy works in the universe, and we can relate that in a real practical way to cattle production systems by looking at differences in surface area associated with the body.
So the surface area gets into efficiency of feed, but also maybe even the emissions.
Well, so we're hoping to learn. We'll figure that out, right? Like that's one thing. That's actually, so there's an awful lot talked about when it comes to methane production,
right?
Because of its concerns over environmental impacts associated with cattle production. There's some data actually out there that would actually suggest that under some circumstances, methane production is not all that bad of a thing, because it actually optimizes how much things can be fermented within the rumen. So what happens is hydrogen. So when in fermentation systems like the rumen, you end up with excesses of hydrogen. So it kind of slows down how fast things can be fermented. So when I'm in like a forage system and you can only ferment so much forage, and that limits the cow from taking its next bite, then the the ability to take this extra hydrogen that's coming off of this fermentation, and that's what's slowing all this down, and put that onto CO2 that gets converted to methane. So you go CO2, which is the most oxidized form of carbon, to CH4, which is the most what we call chemically reduced form of carbon. And so it's the most efficient at a molecular scale at moving hydrogen out of a system. And if you can do that, that allows enzymes in the rumen to function more efficiently, more rapidly ferment forages that are in there. So actually, it's probably, we probably don't want to chase the cow that makes no methane. I mean, that's maybe a little bit controversial. I mean, there's some folks who disagree with me.
Would be very efficient than what
but that's the thing. You might end up with a system where, especially where we're asking a beast to capture the most amount out of a fibrous feed, because that's really cattle's special power, right? As they go out there and they get a bunch of forage and they turn it into stuff, so things that you and I'd be on a pretty hard diet if we were trying to eat that stuff, right? But you know, we can let cattle go out there, they capture all the nutrients in that stuff, and they convert it into something that's actually really high nutrient value for us, right? And so we're definitely going to learn how methane emissions relate with these differences in surface area. And we're going to measure things like intake, because we have feed monitoring systems here at the University of Missouri that let us measure daily intakes. And we're going to relate all those things, and we can look and see how all of this relates at the end. So hopefully that gives us better insight into things like that, into methane emissions and other things as well.
So it looks like this project can help small producers, large producers. It's going to help efficiencies with feed, but also the next step will be we'll find out how it does on environmental impacts.
Sure, that's the whole thing.
That's
we're really trying to optimize the efficiency of the whole system. The beauty is when we can optimize the efficiency, which really optimize our feed costs. It also, we're trying to help carbon capture as well, because we want more carbon which is the primary element in the feed. We want most of that to go into tissues of the animal versus other things, right? Or the more of that we can make occur, then what that does is that results in more saleable beef, more pounds of milk, more things reason why folks feed cattle, right?
And who knows, even maybe less time on the feed lot, less time.
Yeah, so you can end up with less days on feed. There's a lot of different things that, maybe we don't know. I mean, or a lot of these different things can happen simultaneous to one another. It's just kind of figuring out what we're really trying to do is come up with a system that gives us a way to more accurately figure those things out in a real-time setting. So basically go from painting with a really broad brush and maybe go to just a little bit narrower one, so we can paint by numbers or something like that.
Yeah, exactly. All right. Well, Derek, this has been fantastic conversation, and congratulations on this grant. It's going to go a lot of different directions.
Yes, sir. I think
which
so.
is really neat.
Yep, we're excited to do it.
All right. Well, thanks. This is it for Tim's Take, and tune into us next time. We'll see you. Bye.